Hey guys, so today we'll be talking about coin exchange problem. It's a very famous problem, and it's also a problem in CLRS book. If any of you read that book, the algorithms book. But regardless, the problem basically is asking you if you have some amount of money you're trying to reach. Okay, what is the minimum number of coins you could use to reach that target value? For example, here 5 cents. Okay, or $5, doesn't matter. You only have 3 coins: 1 cent coin, 2 cents coin, 3 cents coin. Okay, so each one of these is a single coin but with a different value. And what is the minimum number of coins you could use to get to, for example, a value of 5 cents or $5 or whatever? Okay, so to get to 5 cents, well, intuitively, the minimum number of coins, well, you need 2 cents coin plus 3 cents coin. That will give you 5, which means I needed only 2 coins. That's the minimum number of coins to get to 5 cents. 2 coins. Okay, one coin value 2 cents, another coin value at 3 cents. So you get 2 coins. That's the minimum. You could try anything else, you will never get less than 2 cents. Sorry, 2 coins. Okay, so the number of coins we can use is 2 coins. Now, obviously, if I tell you what about 100 cents, well, that's gonna be hard. It's like you'll have to try so many different combinations. It's pretty hard. Okay, so now, and that's why we need to use a computer for that. It's because if you try to do it by hand, you'll have to try so many different combinations. And since the computer is faster, we will need to use a computer for that. And the computer will try all the combinations for us. Let me go back to the simple example. You have 5 cents you're trying to form. You're trying to form a 5 cents. 5 cents was the minimum number of coins. So what you could do, you could try every single possible scenario using the computer, obviously. Okay. So you have 5 cents, and you're wondering, well, what if I use my 1 cent coin? What if I use my 2 cents coin? What if I use my 3 cents coin? Okay. So if you use your 1 cent coin, you end up having 4 cents left to form. If you have your 2 cent coin, you have 3 cents left to form. If you use your 3 cents coin, you have 2 more cents to deal with or to form. Okay. So the left branch, I use my 1 cent coin, 1 cent. Here I use my 2 cents coin, a single coin. Here I use my 3 cents coin. Okay. And that's how much money I have left with me to deal with. Okay, well, let's do the same thing. Well, now you have 4 cents. Like you're wondering, well, what if I use 1 coin? 1 cent coin. Well, I have 3 cents left. If I use my 2 cents coin, I have 2 cents left. If I use my 3 cents coin, I have 1 cent left. Okay, well, it seems like we're getting closer somewhere. Well, over here I have 3 cents to deal with. That's a possible scenario. Well, what if I use my 1 cent coin? I'm gonna have 2 cents left. You use 2 cents coin, you have 1 cent left. If you use your 3 cents coin, well, you have 0 coins left. Oh, damn, we arrived. Oh, I got 0 coins. I got 0 cents left. Well, looks like I'm done. But is that really the shortest way to get there? Well, let's try the other combinations. But that's a good result. We got to 0 cents left, which looks like we're done, but that does not really mean that's the shortest path to get to 0. Okay, but that's a path. Okay, well, let's see. Here, if I use 1 cent coin, well, I have 1 cent left to deal with. Here, I have 0 cents to deal with. Here, I'll end up having a negative value. So that's not good. I don't want to get there. Okay, so if you notice, we got another 0 cents, which means we're done if we follow that path. Okay, over here, if I use 1 cent, I get 1 cent coin, I get 2 cents left, 1 cent left. Oh, 0 cents left. So notice I also got to 0 cents left in a shorter path. Okay. So I got 0 there, and here if I use 1 cent coin, I get 1 cent left. 2 cents coin, 0 cents left. 3 cents coin, oh, well, I'm gonna end up in a bad situation. Negative number, I don't want to get there. Okay, one more, and I think I will stop there. Okay, so 1 cent left. 0 cents left. Oh, another 0. And then get a negative number over here. Okay. So we got a bunch of zeros, and that's good. Okay, so I got a 0 over here, which is good. A 0 over here, which means I'm done. 0 over here, 0 over here, 0 over here. So ask yourself, how many coins I used to get to that 0? Well, I used 2 coins. Which 2 coins? Well, I used a 3 cents coin plus 2 cents coin. Okay, so I used 2 coins to get there. Over here, I also used the 2 coins. I used the 2 cents, and then I used 3 cents. Now for that guy, I used the 3 coins. Okay, you can follow it. You have 2 cents, and then 1 cent, and then 2 cents. 3 coins here. 3 coins. Over here, I used the 3 coins. Okay, and that's longer path, or more coins than these guys. These guys were only 2 coins, okay? So you notice something. The number of coins used to get to a 0 is the same thing as the depth, or the shortest depth in the tree. Okay? The shortest, the depth to a 0, depth of the tree to a 0 is the same as the number of coins. So for example, to get to this particular depth represent 1 coin used. Okay, and then from here to here, that's another coin used. Okay, so so the question is, how many levels did we use? How many levels in the tree to the first 0? What is the shortest path to a 0? Okay, which means that the number of levels we had to go through to get to a 0. Okay, and also here, from here to here, that's also another coin. So if you notice, the tree has actually, it can go deeper than that, because I think over here that's like 1, 0, negative. The tree is as deep as I think 4 levels, or even 5 levels. Okay, I think if I continue here, that will be 1, negative, negative. So how many levels overall in that tree? Well, that tree, I think overall has 3, and then has 4, and then has 5. Okay, so 1 coin to get to the very bottom. But you don't want that, okay? Okay, so the tree depth over here is 5, but we're looking for the shortest path to A0, okay? Okay, so what can we do? So let me erase all that, because I need some space. And here's what we can do. We can ask each one of these coins to collaborate with us, okay? So what do I mean? So for example, okay, let me also erase that. I hope that makes sense. I'm gonna erase all that. What we can do, let me also erase this. Sorry guys, I'm gonna erase that. Erase, need some space. So what happened is, oh my god, I also need this guy. This will be 0, and then this will be negative, and this will be negative, okay? So what could happen is, this 0, once I get to A0, this 0, or this function call, you could pretend that this is a function call, which is going to inform its higher ups, or its leader, hey, I am at the very bottom. Okay. I am 0 levels away from the end. And this guy will tell his leader, by the way, there is no way you can get to 0. So I'm going to give you some big number indication that there is no way you can get to 0 from my path. And this guy will tell his leader, by the way, there is no way you can get to 0 from my side. And this leader over here will have to make a choice. He got 0, he got infinity, and infinity. He got 3 values. Which one that leader should take? Well, he should take the shortest one, in that case, 0, okay? Which represent how far it is, how far this guy to the bottom, okay? So my point is each one of these little nodes is going to inform its leader how far it is from the bottom. So this guy will say, hey, I'm actually at the very bottom. I'm 0 levels away from the bottom. This guy will say, hey, I am forever away from the bottom. Hey, I'm forever away from the bottom. There's no bottom. It's a rabbit hole. And then the leader will collect the results and will say, okay, well, how far I am from the bottom? Well, one of my workers told me he's at the very bottom. He's already at the end. Okay, so this guy will take the 0. Okay, he's not gonna take the infinity or the infinity, and is going to tell his leader, hey, by the way, I am 1 level away from the bottom. Why is that? Well, because over here, he got the minimum value from his worker, says, hey, I'm 0 level from the bottom. And then that means this guy over here, the 1, is 1 level away from the bottom. That's the shortest way to get to the bottom. Okay? And this guy will say, by the way, I am 0 levels from the bottom. I am at the very bottom. And this guy will say, by the way, I am forever away from the bottom. So I should make it an infinity, not 8. Then these two will have to make a decision. Well, shall I take the 1? Should I take the 0? Or should I take the infinity? Well, it's better to take the 0. Take the minimum one. Take the shortest path. So 2 will say, I need also to erase this guy. 2 will pick 0 as the winner of the 3 values. And then we'll tell the 5 over here, hey, by the way, I am 1 level away from the bottom. Okay? 1 level away. Why is that? Well, because this guy is 0 levels away from the bottom. That means the 2 is 1 level away. It's 1 plus the shortest path to the bottom from your point of view. Okay? Okay. And then 5 at the end will tell whoever calls it, hey, by the way, I am 2 levels away from the bottom. Okay? And that will be the final answer. So you notice few things. Every one of these subtree roots is collecting answers from its subtrees or workers, whatever you want to call it. Collecting answer. Gets an answer from this guy, an answer from this guy, an answer from this guy. And each root, for example, this root, will have to make a decision. It collected multiple values and needs to take the minimum value out of these multiple values. Why it takes the minimum value? Because we're looking for the shortest path. Okay? The shortest path to the bottom. The bottom, which is A0. Okay? And then every time it collects a minimum, it tells its manager, hey, by the way, from my perspective, the shortest path to A0 is this value. Take it. And so on and so forth. Okay? Okay. Notice, let's pick an impossible scenario. And I tell you, you're trying to form a target, for example, is 3 cents. You only have 2 cents coin, a single coin of 2 cents, okay? Well, yeah, 3 cents. Well, you can only use 2 cents. Oh, let's make it even Let's actually make it a little different. Let's make it 2. Let's make it 5, okay? Maybe let's put 8 here. Okay, well, 8 cents. If you use a 2 cents coin, you get 6. And if you use 5 cents coin, you get 3. If you use 2 cents coin, you get 4. 5 cents coin, you get 1 cent. If you use 2 cents coin, you get 1 cent left. 5 cents coin, you get some negative number. 2 cents coin. Actually, no, I picked, no, I need to change the value. Let's make it 7, sorry. I'm trying to create an impossible scenario. Okay, sorry. If I take 2 cents, I get, don't give me 5. No, I need to get an impossible scenario. Let's pick it 4. Actually, yeah, 4 will work, okay? Okay, so, yeah, sorry. So if I take 2 cents coin, I get 5. 4 cents coin, I get 3. Is that right? Yep. Now if I take 2 cents coin, I get 3. 4 cents coin, I get 1 cent. 2 cents coin, I get 1 cent. Will be a negative. I use 4 cents coin. And then if I use 2 cents coin, I get 1 cent left. 4 cents coin, I get some negative number. 2 cents coin, negative number. 4 cents coin, negative number. Negative number, negative number. Okay? Yeah, that works. Now, let's read what we did earlier. Well, this guy will say, oh, I only have negatives. Okay, this will give you a negative here, which means this will tell him, hey, I have, there's a forever, it will take forever to get to a 0. There's no way to get to a 0. And this guy will tell him the same. Okay? There's no way to get to a 0. And this guy will tell him, hey, there is no way to get to a 0. Okay, well, the one will tell the 3, hey, there is no way to get to a 0. This will tell him, hey, there is no way to get to a 0. Hey, there is no way to get to a 0. Okay? And this will say, well, hey, 5, there is no way to get to a 0 from my side. This will tell the 5, by the way, there is no way to get to a 0 from my side. And this will, and so on. This will say, oh, there is no way to get to a 0. There is no way to get to a 0. And this 7 will collect all the answers. No way to get to a 0, no way to get to a 0. So 7 will say, you know what, there is no way to get to a 0, okay? But in LeetCode, what they want you to do, if there is no way to get to a 0 at all, or at the end, you need to return -1, okay? So what we're supposed to do, we need to return -1 at the very end over here. So if the very top of the tree could not find an answer at all, we're supposed to return -1, okay? So keep that in mind. Okay. Okay, so shall we start writing code? I think so, right? I think it's clear. I hope it's clear. Okay, so let's get to LeetCode. Oh, sorry guys, I'm back. Okay, so that's the problem. Let's get started. Okay, so what's the first step? The first step is I need to keep creating more functions and more leaders and workers. Okay. So what do I need to do? I need to create an inner function. Let's call it DFS. Okay. And let's call the value it takes remaining amount. Remaining. Okay, so what do I do? This, by the way, represent a single node in my tree. So I'm creating nodes over and over and over. I am iteratively creating more nodes. Okay. So you see, if I go back over here, each one of these nodes, this guy, I'm creating them using a function call. So each one of these nodes represent a single DFS call, okay? So I'm creating so many DFS calls, okay? Okay, so let's go back. Okay, so every time I create a DFS call or a new function call or a new node in my tree, I'm wondering, is the value that I'm receiving from my leader, from my higher ups, so is this value, if that value is equal to 0, is it less than 0, is it a negative value? Well, if it is a negative value, what does that mean? It means there is no way from my side I can get to a 0. I'm at the very bottom, I'm at negative value, and if I keep using more coins, I'll get more negative. Which means I should tell my manager or my leader, hey, it's impossible to get to a 0, so I'm gonna pass an infinity to my manager or to my leader. So, okay? Okay. So you can think of this as this is the value that I'm currently have, and I'm wondering, can I get to a 0 or not? Well, if the value that I have right now is equal to 0, well, hey, I'm at the bottom. Tell my manager that I'm at the bottom. I'm at level 0. Okay? I'm saying send to my leader or to my parent node, I guess you can use that term too. Tell my parent node that I'm actually at the bottom. Tell him that. Okay? And here it says to my parent node, to my leader, hey, there's no way you can get to 0 from my side. So it's infinity. There's like forever. Okay. So otherwise it means I need to try every other coin possible, okay? Every other coin. Which means I need a for loop because I want to iterate over every single coin and try and see what value can I get from there, okay? So for coin in coins, then I'm wondering, I need to create my sub trees or my children. I need to spawn new children or new workers. Okay. So I need to create a function call for every coin to create more subtrees or more workers. Okay. More children. And for each child or each worker that I'm creating, I am passing the value that I currently have, which is the remaining amount, but minus the coin value that I'm iterating through. Okay. So I'm like, hey, I'm like telling my worker or my child node, hey, try this value, try this coin, try this coin, try this coin, try this coin, try this coin. Okay. And once my worker or the child node is done, it's going to send me some value. So I want to pick up that value and store the answer somewhere. Let's call it current. Let's call it current path. Current path. Okay. Coins maybe. I don't know. Some just current path. Whatever. Okay. So that represented a value that I'm getting. This function call is going to give me an answer for the number of coins, the minimum number of coins from that particular path. Okay, so I'm collecting answers from my my children or my workers. I'm collecting answers. Okay, so now I'm collecting answers and I need to compare those answers and see which one is the minimum value. What is the minimum value among these answers? Okay, so what I need to, how do I do that? Well, I cannot keep using the same variable because that will be overwritten because I'm inside a loop. I don't want this value to be overwritten, so I need another variable, and then I can use it to keep track of the minimums. So I'm gonna create another variable, num of coins, and I'll give it the value infinity. Okay. Now, why I'm giving it the value infinity? Well, because infinity does not get impacted by taking minimums. Sorry, positive infinity. So for example, if I take the minimum, maybe I put a comment here. What is the minimum of infinity, 3, and 4? Well, it will be 3. Infinity made no impact on getting the actual minimum value. So that's why we're using a placeholder, a value infinity, because no matter how many numbers I'm taking the minimum of, for example, I put 1 here, infinity played no role, does not impact the answer. So I need some placeholder. And the best placeholder is the value infinity because it does not impact getting minimum of a series of numbers. Okay? Even if I put, I don't know, imagine negative 10. Okay, the minimum is still negative 10. Okay, infinity does not impact it, so it's a good placeholder. Okay. Okay, so that's why we're using a placeholder infinity, and basically what I'm trying to do, okay, I'm using that placeholder, and I'm wondering, is the value that I got from one of my children, is that lower or smaller than the current value that I have, or the placeholder, which is number of coins? If it is, replace the number of coins with the new value that I have from my child or my worker. Okay. So what's happening here is I'm iterating over each, I'm collecting the answers from each node or child node or a worker. I'm collecting the answers. And for each answer I'm collecting, I'm checking, is that answer lower than the answer I got from the previous child or previous worker? If it is, update the minimum. So I'm iteratively updating the minimum value that I'm collecting from my children or my child nodes or my workers. Okay. Okay. So now I got the minimum answer for my children. What I need to do now, I need to inform my manager. I need to inform my manager, hey, I checked with my children, and I want to tell my manager or my parent node, hey, the minimum number or the minimum number of coin or how far I am from the bottom is whatever I got from my children plus 1. Why plus 1? Because I'm taking into account that I'm one level above my children. Okay? So basically, I'm sending a message to my leader or my parent node. Hey, by the way, I checked with my kids or my children and I got the minimum value from them. So basically, from my perspective, I'm one more level to the bottom compared to my children. Okay, how that makes sense? I really hope that makes sense because that's actually the whole story. So if we go back to my graph, I know I'm talking too much, but I really want to make sure that this is clear. Basically, what we did, we collect every parent node. For example, this guy over here, the 2. For example, over here, the 2. Or actually, yeah. For example, let's look at the 3 over here. It's collecting the answer I got from this guy, collecting the answer I got from 1, collecting the answer I got from 0. After I collected the answers, it looked for the minimum value. So 2 will tell her, hey, by the way, I am 2 levels away from the bottom. 1 will tell her, well, I'm 1 level away from the bottom. 0 will tell her, I'm actually at the bottom. So what the 3 is going to do is going to compare 2 with 1 and 0 and then get the minimum. And the minimum will be 0. So it's going to tell the manager, hey, by the way, I am 1 level away from the bottom because my child node is 0 levels away from the bottom, which means I am the parent 1 level away from the bottom. And what this for is going to do is going to do the same thing. It's going to collect the answer from this guy, collect the answer from this guy, and then get the minimum. And then tell its manager, the leader, the parent, whatever. Okay, that's basically what we're doing. Okay, so let's go back. I need to use a bathroom, so I don't want to cut the video short. Okay, so what do we need to do now? Well, we need to call our inner function. Inner function, so our inner function called DFS. That's what the one we're using to create those subtrees or children. So we need to call that inner function that we're using. I need to remove some spaces here. I have so many space. And I will give it the initial value I started with, which is amount. Okay, so I'm gonna give it amount. And at some point when this DFS is done, it's going to give me some answer, okay? The final answer. And remember, the final answer could be infinity. So I need to check if result is it infinity or not infinity. Well, if it is infinity, that means there is no way to get to a zero. If it's not infinity, it means there is an answer. So I'm gonna put else here. If it is infinity, that means there is no way to get to an answer. So I'm gonna return -1. That's an instructions of the problem. But if it's not infinity, that means there is a way to get to a zero. There is an answer. So I'm gonna return the result. Okay. Okay. So basically, this last part over here, that's the scenario which I covered earlier, which is that one over here. That it's possible that there is no answer at all, which means I'm just collecting infinities, and then at the very top level over here, it will end up collecting infinities and comparing infinities. Well, in that case, there is no answer, and LeetCode problem tells you, well, there is no answer, return -1. So at the very top level over here, the very top level, if I end up having infinity after all, only infinity, nothing less than that, well, that means there is no way I can get to a zero, so I return -1. Okay. Okay. So let's try running this answer, and let's click run. User is not authenticated. Oh my god! Oh please. Oh, I need to log in. Oh my god! Forget it. You know what? That's actually an answer. Try it on your own. I'm not gonna re-log in and redo the video, honestly. But if you try it, that should work. Okay. And in the next video, we're gonna tweak the solution a little bit to make it faster, and I'm gonna go over the runtime. Okay, sorry guys, but I need to use the bathroom.